We are going to be doing section 2.4, which is creating and solving inequalities. So the first one is less than. And so you guys should definitely remember these from even elementary school. The next one we have is greater than. And then now we have kind of the same symbol, but with a bar underneath, which means that it can be either less than or equal to. And on this one, we have greater than or equal to. And lastly, we have an equal sign with a line through it, which means not equal. Okay, so we're going to start off with doing review problems. Review meaning you should have learned these last year, but I'll still teach them as if you don't. So solving linear inequalities. When you do this, you're going to treat it like it's an equation. So you're going to solve it the same way. In other words, I'm going to isolate the x. I'm going to kind of ignore that inequality sign right now. So in order to do that, I would need to subtract 3. So I would get x is greater than, and 7 minus 3 is just 4. So easy. So what that means is your answer is not just one thing like an equation. This has multiple answers. So it's saying that the answer is greater than 4, which means it could be 4.1, it could be 1 million, it could be 500. So anything that's bigger than 4 will make it true. Now I'm gonna go ahead and do the next one. So it is your turn. So go ahead and pause the video and try on your own. So for this one, we'll see if you guys got it right. I'm going to subtract 2 from both sides. So we get negative x is greater than 4. Now this is something I'm not sure how many of us remember, but whenever I divide by a negative number, in this case I have to divide by -1 to get rid of that negative, so it's not just negative x. Anytime you divide by a negative number, when you bring down the inequality sign, you actually have to flip it. So 4 divided by -1 is -4. So this means any number that's less than -4 will make it true. All right, our last one here. So I have the fraction 2/3 times x minus 1 is less than or equal to 12. I don't love fractions, and so I like to get rid of them. So to do that, whatever's on the bottom of the fraction, you can multiply everything by. So I'm going to multiply both sides by 3, which will eliminate the 3, which means I only have the 2 times x minus 1. And then I keep the inequality there, and then I multiply 12 times 3, which is 36. From there, I'm going to go ahead and divide by 2. So I get x minus 1 is less than or equal to 18. And truthfully, we don't really need those parentheses anymore. So again, I'm still trying to get that x by itself. So I'm going to add 1, and I get x is less than or equal to 19, which means 19 would work, or 18, -7, anything that's less than or equal to 19. So now I'm going to go ahead and put that note that we talked about. So when you divide or multiply by a negative number, you flip the inequality sign. So that's super important to know as we work on these. Okay, so flip inequality sign. All right, so the next thing we're going to do is look at a couple of word problems. So Anaya has $20 to spend on a $12 shirt and 2 accessories. How much can she spend on each accessory? Okay, so let's think about this. We know she has $20 to spend. She has a $12 shirt already. She wants 2 accessories, but we don't know the cost. So we're going to say x is equal to the accessory cost. Okay, now let's kind of see what information we have. We know she bought a $12 shirt, so that doesn't need a variable. That's just $12. Now, we also know that she wants to buy 2 accessories, so 2 times whatever the accessory cost is. And then we know that something to do with $20, right? So if it says that Anea needs to spend exactly $20, that's when we would use an equal sign. But it says Anea has $20 to spend, which means Anea can spend less than $20 or she could spend $20. So when we're deciding what inequality, think of this as the amount of money Anea is spending. That amount has to be less than or equal to 20 based on the fact that it says she has $20 to spend. Now I isolate that x. So I'm going to go ahead and subtract 12. So I do that, I get 2x is less than or equal to 20 minus 12, which is 8. Then divide by 2. I don't need to flip the inequality sign because we weren't dividing by a negative. Now, when it comes to writing my answer, the question asks how much can she spend on each accessory, and if my answer was x is less than or equal to 4, that doesn't really make sense. So what really makes sense is she can spend $4 or less, I should say. So she can spend $4 or less on each accessory, but I'm just going to write that. Okay, moving on. So moving on, we're going to look at another word problem. So this time we have Aiden is buying 12 uniforms, so we know that's important, for wrestling. Each uniform has an additional charge of $3 for printing. He wants to spend at least $100 to get a discount. What is a possible cost for the uniform? So the thing that we don't know is cost of uniform. So I'm going to go ahead and make that our variable. Okay. We know that he wants to buy 12 uniforms, and we know that each uniform has an additional cost of $3 for printing. So probably the most common mistake is a lot of people want to do this. They want to say there's 12 uniforms times the cost plus that $3 additional charge for printing. The problem is that's only doing the $3 once. So we're going to kind of rethink this. So we're going to think of it from the uniform standpoint. We have a uniform that we don't know the cost of. So that's the cost of the uniform. Each of those uniforms we have to add $3 to. Now, each uniform plus the $3, there are 12 of those. So that's how you're going to set it up. He wants to spend at least $100. So I'm going to put 100 here. We know that the amount of money, which is this, has to be greater than or equal to 100. So at least means you can spend 100 or you can spend more. So now we're going to go ahead and distribute. So I get 12x plus 36 is greater than or equal to 100. And now I'm just isolating this x. So the next step would be to subtract 36 from both sides. So I get 12x is greater than or equal to 64. And then I'm going to go ahead and divide by 12. So when I divide by 12 from both sides, I get kind of a weird number. So we typically in this class round to the nearest 100th, which means 2 decimal places. So this is going to be x is greater than or equal to, and we're going to get 5.33. And it does make sense to round to the nearest 100th because we are talking about dollars. So we usually have cents in hundreds. So what this means is he can spend at least $5.33, which is nothing, on each uniform. Okay, So moving on to the next thing, and it's very important you're doing what I just did. You're writing that sentence, because just writing the inequality answer isn't answering what the question was asking. So the next thing is solving inequalities with variables on both sides. So we've done with this already with equation, so it's pretty similar. We just have an inequality sign now. So I'm going to start off by distributing that -3 to both parts. So -3 times 9x is -27x. -3 times 20 is -60. Then I just write that inequality sign and I bring down the rest. So now I want to get the numbers on one side and the variables on the other. So I'll add 60. You could have added 27x. There's a lot of different ways you could have done this. So I get -27x. Those 60s cancel. I bring down my inequality sign. Then I get 15x, and I have -20 plus 60, which is 40. Then I'm going to go ahead and subtract that 15x. So I get -42x. I bring down my inequality sign, 40. Now to get that x by itself, I have to divide by -42. Now if you remember, going back to that red star, when you divide or multiply by a negative number, flip the inequality sign. So we need to do that. So I'm going to have x, and then instead of greater than or equal to, I'm going to have less than or equal to. And we have -40 over 42. It doesn't really matter where that negative sign is. And to go further, we can divide both parts by 2. So we actually get -20 over 21. Okay, so we're going to keep going. The last problem is a word problem with creating an inequality with variables on both sides. So we have Club Sport charges a membership fee of $250 and $50 per month. And then Costco charges $80 per month. We want to know, when will Costco be more expensive? So what we're going to do is create two equations. So we'll start with Club Sport. So we have a membership fee, which is a one-time fee, which means it's a constant. It will not have a variable. And then we have to add $50 per month. So we're going to say that X represents months. Now we're going to look at Costco. So Costco doesn't have a membership fee. So we just write $80 per month. Now, with our equations, we always wanted to know, when will they cost the same, which means we would set them equal to each other. But in this case, we want to know, when will Costco be more expensive? So I'm going to go ahead and write out both expressions that I've created. Now I just have to decide on the sign. So this is Costco. I want to know, when will that be more expensive, which means when will it be greater than. So now I go ahead and solve it. So I'm going to go ahead and subtract 50x from both sides. So I get 250 is less than 30x, and then I divide by 30. So when you do 250 divided by 30, you end up getting 8.33. But when we pay fees, monthly fees, we pay them at the end of the month. So 8.33, we wouldn't really say that. So since it has to be more than 8.33 months, 8 months wouldn't be enough. So after 9 months, Costco would be more expensive. Okay, so that's everything for this section.